Alright folks, in 2.4 we're going to cover a different type of display of data, and that is box plots. And hand in hand with that we'll talk about quartiles, percentiles, and the 5-number summary that shows up on a box plot. So starting out, we're going to deal with our quartiles, and those are just kind of like they sound, what split our data up into quarters. And when we're talking about quartiles and percentiles, they're represented as a percent. So we've got 25%, 50, 75 to talk about what we relate to as our quartile 1, quartile 2, which is our median, and quartile 3. So when we relate those to percentiles, our first quartile, or Q1, is the 25th percentile. Same thing with second quartile or median, that's the 50th, and the third quartile is the 75th percentile. Now, we'll go a little bit more in detail about percentiles later in the video, but I want to really emphasize now that percentiles aren't an exact science unless we have a lot of data, meaning percents deal with 100. If we have more than 100 unique values, then we can be realistic with, the 75th percentile actually being a defined value, but they don't always hit in a nice spot, and we'll see that as we work through some examples here. But in general, when we're talking about percentiles or quartiles, it's just talking about splitting our data up numerically in order, and talking about how those values that we're focusing on relate to the other values in the set, or the order of the other values. Okay, so it's relative position. So first thing we're going to do is hit on the pieces of a box plot, which are the 5-number summary, dealing with those quartiles, as well as the minimum and the maximum. So we're going to look at all of the pieces of box plot for this one example where it's dealing with highway fuel economy of 25 2018 Toyota 4Runners, and all of their values are given here. It looks like they're already listed numerically. In general, that's our first step when we're working with data, is put it in order so that we can analyze what's going on. Okay, so we talked about the pieces that go on here. They relate to the box plot like this. So our minimum is going to be our lowest value on the box plot, and sometimes it's connected to what we call this bar here, the whisker, and sometimes it's a separate piece. So the 5 numbers that are important and make up our important features of the box plot are the minimum, Q1, median, which is quartile 2, Q3, and the maximum. And if any of those, the minimum and maximum, are represented as separate points, that would indicate that they are outliers. Okay, so in here, it shows that there are 2 outliers on this one, and they're determined mathematically by what we call the 1.5 IQR rule. So we need to talk about this IQR. So range of data is the difference between the minimum and the maximum, essentially how spread out your data values are. When we talk about IQR, it's inner quartile range, or how spread out your quartile 1 is from your quartile 3. So we find that just by taking Q3 minus Q1. So what we want to do to determine outliers is use the 1.5 times the IQR. Essentially, visually, that means the length of this whisker can't be more than 1.5 times the length of the box, or it would just be too spread out too long. Okay, so visually, we're saying that this distance here is more than 1.5 times the length of that box, since it's showing up as an outlier instead. But here's the math for it. We're going to take the edge of the box, and we're going to subtract 1.5 times that IQR, and that will create a boundary for the longest possible whisker. Anything lower than that would be considered an outlier. Similarly, on the other side, we can take the edge of the box on this side, add 1.5 times the IQR to create a boundary, and anything past that on that side or bigger than that would be considered an outlier. So with our numbers, Q1 up here was 22.2, subtract 1.5 times the length of the box, or the distance between our Q1 and Q3, and that gave us a boundary of 21.6. Well, that shows up right here. That's the longest possible whisker, and our number was smaller than that, so it was considered an outlier. Similarly, over here, we add 1.5 times the IQR. That was 23.2, which would have shown up right here. our number was larger than that, so it was an outlier. There's no rule to how many outliers can exist. This one had 2, some will have none, and some can have many. Depends on the distribution of the data we're working with. Okay, so we'll practice calculating the 5-number summary and IQR here in a little bit. Okay, but I want to talk just a little bit more about overall shape and how we can use box plots to compare data. So looking here, it says students in an introductory statistics class were presented with a page containing colored rectangles. And then from that, their task was to name the colors as quickly as possible. Okay, so from there, they recorded the times to complete this task and compared the scores between men and women. So what I want you to do is take a look at this picture here in your different box plots, and I want you to pause the video while you think about what's happening and any trends that you notice. Okay, once you're done thinking about what's going on here, you can come back to the video and we'll talk through some of those things. So hopefully overall you notice that in general males had higher values along this axis, and what that indicates for us is overall males took longer than females to complete the task. Okay, and that means as we were looking through here, not only is the maximum time bigger, but if you look at all of those individual pieces, remember this is maximum, Q3, median, Q1, and the minimum. Every single one of them for the males was larger than the females. You know, even the excuse me, even the slowest female, a lot of males finished after that. Okay. So that's something we can do easily with box plots, is we can make comparisons between two groups. Another thing that's really good to observe from box plots, which didn't occur here, is you can notice the shape, and you can notice if there are any outliers that are present. Okay, so I'm just going to make a note here. Look for the shape, meaning are they more skewed or symmetric, and I'll show you what that looks like here on the next example. But it also helps you determine outliers. Okay, so in general, those are some really good things that box plots help us with. Comparing two different ones like we did here, and then talking about if there's skew showing up or outliers, any extreme values. Okay, so let's answer some more specific question relating to this, and this may bring up some of the things that you may have noticed when you were thinking about comparing these two things. So the first one, true or false, the 75th percentile for females represents all females who had times less than or equal to 20 seconds. Okay, so when we talk about a percentile, okay, the formal definition means that if we're referring to the 75th percentile, so first of all, that relates to Q3 from what we talked about above. So right here, this score of 20 seconds means that 75% of the people who took this test, the females who took this test, were completing it at 20 seconds or faster or better. It does not mean that all females less than 20 seconds is the 75th percentile. The score of 20 exactly represents the 75th percentile, not everything below it. So this one is false. Okay, so the score of 20 seconds is the 75th percentile. So only females with that exact time score in the 75th percentile. Okay. So now, the next one, what was the slowest task time for females? So we're going here. The slowest for females would be not the lowest, but the highest, so that was 24 seconds. Okay. And then it says about what percent of male participants took longer than this. So what I want to emphasize on a box plot is that every single chunk here, no matter the length of it, represents 25%. So from the minimum to Q1 is 25% of the data points. From Q1 to Q2, or the median, is 25%. Another 25%. And even though this is way longer, okay, this is as long as, or longer than the whole box, this is still 25% of data. It just means that more values fell in here and less values fell through here, okay? So groupings of those ideas can help with the relative length of each of those sections. It tells out how spread out our values are. Similarly up here, this is still 25%, 25%, 25%, 25%. Okay, so there were the most in this period of time in terms of compactness. Okay, so here we want to know about what percent of males took longer than this. So here it would look like one chunk of our box plot, so about 25%. Okay, I really want to emphasize we know nothing about how many individuals took this based on a box plot. We only know percentages, or how the data is broken into those 4 chunks. Okay, so we can talk about shape. We can't talk about specific numerical values unless they are parts of our 5-number summary. Okay, this last one, roughly what percent of male students completed the task in 24 seconds or less? I'm going to have you pause the video and see if you can answer that question. Okay, hopefully you got this from the last one. About 25% took longer, so then the rest would take 24 seconds or less, so that would be about 75%. But also, 75% is the 3rd quartile, so that's 1, 2, 3 chunks. Okay, 75%. Alright, here's where we could talk a little bit more about shape, like I promised. Okay, so when we're looking at this, if one whisker is longer than the other one, we can say that there's a skew happening. Okay, and it's happening in the direction of the longer whisker because of what we talked about. This is 25% of the numbers. Okay, so let me give you an example here. Let's suppose that this data set for University C had 40, I'm picking a nice divisible by 4 number, okay, 40 people who were in University C. That would mean 10 people represented in this part of the box plot, 10 people in this one, more clustered together, 10 here, and 10 here. So there's 10 people being way spread out along these values from 60 to maybe 75, 76, okay, than there are in the rest of it. So it's most of them are here, but there's some spread this way towards the left, so this is negatively skewed or left skewed. I'm going to have to pause my video here because looks like, oh, nope, we're okay. My Excel glitched for a little bit there. Left or negatively skewed. I talked about last time, negatively is usually used for continuous data, whereas left skewed is more for those discrete dot plot type things. I don't care which one you use. For me, they can be used interchangeably. You just need to be able to recognize when you see those words, they mean the same type of picture. Okay, University B. Okay, similarly, we've got a longer tail over here. So we have a little bit of a skew to the right. Now I say a little bit because this median being over here means it's not quite as skewed as the other one, because let's suppose we're working with 40 in. 10, 10, 10, 10. There's about 20 people on this side and about 20 people on this side. So there is a gap in where these numbers are meaning why this box looks so long compared to it. But we're going to focus more on the whiskers. That's what I want you to do for this. So we do have a positive skew going on for this one. Okay, so we can say right or positively skewed. Okay. And then University A, from the middle out, it's not enough for the whiskers to just be symmetric. What you want to do is imagine folding your box plot in half along the median. We want the boxes to the left and right to be relatively symmetric as well. So this one, that is happening, so this one is symmetric. All right, now we're going to get to work with some numbers here. It says the data set below represents the number of hours of homework completed in 1 week by high school students. So we've got some numbers here. The first thing we want to do with a set of numbers is put them in order. And to me, the easiest way to do that is to put them in a list going up and down. Okay, there's a couple ways we can do this. So if you highlight this first row, just one, and do a Control-C, that will copy it. Okay, so highlight that, Control-C, and then over here, go way up high so we have space to put both columns. We're going to right-click, and here there's Paste option where you can paste and transpose it, and that changes it into a column. Okay, that's what I like to do the best. There's also an Excel function that's equals transpose. I'm just going to show you real quick. Okay, you can do it that way as well. I just would rather copy-paste, but just wanted to show you that. We're going to do the same thing here. Select, and then Control-C, and then right-click below it, and use that transpose paste option. Now that we have them in a list, we're going to highlight them all so that we can order them. Okay, so remember that sorting feature is under the Data tab. Okay, and I'm just going to sort them like that. Okay, the way I type these, it looks like the functions are a little bit weird. If that bothers you, you can go to the Home tab over here, and you can change the formatting of these to all numbers or all general, and then change, you know, your alignment. Okay, so now they're in order. We could do the 5-number summary by hand looking at a lot of these things, but I want to talk about how Excel can do some of these for us for when we have a set that's more than just 20 numbers. Okay, so here, let's start with our 5-number summary. What it consists of is the minimum, Q1, the median, Q3, then the maximum. So we've talked about the minimum and the maximum already, so equals minimum. Again, our numbers are in order. We can visually see this, but we want to practice using Excel for those instances where the data is more messy. Okay. Similarly, you can do some of these features without sorting them. You're not going to be able to do Q1 and Q3 without sorting them. So there's the minimum. Maximum, we're going to do the same way. We know it's 20, but let's use the function. Double-click equals maximum. That'll give you that. And then median also has that same feature, equals median. And it will find the middle value of your set as well. So it ended up being at 6. Okay. What we're going to do here now is talk about Q1 and Q3. Okay, quartile 1 by definition was the 25th percentile, right? Or the quarter of the data, or where that hits. So the first thing I'm going to have us do over here is talk about where the middle falls. So we've got a list here of 20 numbers, and the middle of that would be 10, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here is the top half. Okay, I'm just going to highlight that in a different color. And then the bottom half. So our median is actually not a part of our set. It fell between 6 and 6, and it ended up being 6 because of that. But our Q1 is the median of the lower half, not including the median itself. So if we did have a set that was odd, instead of having 20, and I double checked a little bit ago, might have heard me counting that it really was 20, that I remembered, right? But if we had an odd set like 21, the median would fall on a number in the set, and you would not want to include it. So we want to make sure we're doing that. Similarly, the Q3 is the median of the upper half, not including the median. So we can find Q1 by doing equals median and then just selecting the upper half, or the lower half, excuse me, of that data. It's upper on this part, but the lower numerical values. Okay? Now, this happened to be equal distance between the 2 and the 6. That's just by chance. Okay? It does not happen that way normally. It just was that way because of how our numbers looked. There's no rule to say how these numbers compare in size. We see that based on not all box plots are symmetric. Okay? We're going to do the same thing for Q3. We're going to do the median of the upper half, and that's from here down to get that value. Okay, and it fell between 2. This one also fell between 2. You just didn't see that, you didn't see it coming out as a decimal because it was between 2 4s. But that is our 5-number summary. Okay, then it says identify any outliers using the 1.5 times the IQR rule. So that's our upper and lower boundaries that we need to find. So I'm going to have you just write low end and high end. And what we're going to do is use our formula to find those boundaries to determine if our numbers fall within that or outside of it. Now visually, I hope you can see this 20 is way different than the other numbers, so it is going to be an outlier. But we never want to assume something's happening when it's closer than that, so that's where this math is coming into play. So first thing we're going to do is calculate the IQR, because that's part of our formula. And that's, remember, Q3 minus Q1. So we're going to just select that, minus, select that, and it's 3.5. Okay, I'm just going to put a note here. That was our Q3 minus Q1. So you remember what you did. Okay, and then our low end, we're taking our Q1, and then we're subtracting 1.5 times, just use your little star, that IQR. Okay, so it means if we had something lower than negative 1.25, it would be considered an outlier. Well, hopefully you realize that numbers of hours of homework can't be negative, so we have no outliers on the low side. Then for the high end, we do Q3, and we're going to add 1.5 times the IQR. And 12.75 would be the highest number that would be okay to have. Anything larger than that would be considered an outlier. So we have an outlier because it falls outside of these boundaries. So we're going to say 20 hours is an outlier since it fell outside of the interval negative 1.25 and then 12.75 hours. Okay. Those numbers are okay. Anything outside of that would be considered outliers. Okay. So what I'm going to have you do is, from the work we've done, can you go backwards? Because you're going to be asked to do a lot of this on your homework. Can you look at a box plot and interpret some of these pieces? Okay, so for this part, when I say low and high, I mean, are there any outliers on the low end? Are there any outliers on the high end visually? I'm not asking you to calculate the low and high boundaries. Okay, these are the outliers on the low end and the high end specifically. Okay, so pause the video and take care of that for me. Okay. This one is a look and get with one exception, and we're going to go back up here and fix this one as well. I did a really good job of this in the sentence, but I did a really terrible job of it right here. When I say the minimum is 2, I mean the minimum is 2 hours, and that's why I moved this way over here so that I could label it, and then I went and forgot to go label these. All of these are numerical values related to the original set of hours. They need that same label. Okay, so here, when we're talking about the minimum, it's not just 8, it's 8 points. Q1 was 14 points. The median was 17 points. Just going in order on those important things. Q3 is 20 points. The maximum is literally the highest number in the whole thing, so that is 30 points. Okay, that means this 22 is just literally the second highest value after the outlier was taken out. Okay, so it's important for the feature because it gives more of an idea of the spread of the values. It shows the gaps that is happening here. Otherwise, we wouldn't know how many values are clustered within here. This is showing us 25% of them, except for one, is within 20 and 22, but then there's just one weird one that was out far. Okay, IQR is the length of the box, so that is 6 points. And outliers, we had no low outliers. We had one high outlier of 30 points. And that's it for that one. Okay. Last thing we're going to do is talk about calculating some percentiles that aren't quartiles. Okay. There are some formulas for this, but what I'm going to do is actually come back to this formula, and I'm going to talk about how we can answer some questions using a table, and then I'll relate it back to how this works, okay? So, looking at this first one, it says, suppose that 40 members of your company are given a screening test for a new position. These scores are reported in the table below. To inform potential employees of their screening test performance, you wish to report various percentiles for the test scores. So they want to give, hey, this is the 10th percentile, meaning 10% of the people who took this scored this number or less. So if you scored around there, you were on the low end. Similarly, this score goes with the 88th percentile. Therefore, if you scored that number or better, you would have done better than 88% of the rest of the people who took it. So it gives you kind of how you did in terms of other people who took the test, rather than, you know, a percent based on how many you got right or wrong. Because if it's a really tough test, you're not going to see lots of 90s, 95, 100s. The best score could be a 75%, and that would mean that you are the best person for the job, even though you didn't get 100%. Okay, so that's why percentiles can be helpful. So what I'm going to have you do is, let's go ahead and copy this data, and I'm just going to put it in a new worksheet. That way we don't have to worry about going too much back and forth here with our work. So Control Copy, and then let's just add a sheet, and we'll do it fresh in here. Control V to paste. And what we're going to do is put this in one column again, just like we did with that other one. Okay, so one row at a time, Control C, and then we're going to paste it, but transpose it. And the second one, Control C, all the way down. Okay, you could also highlight these columns. It's just faster to do it this way, because there are less rows than there are columns. Once we have these done, we are going to, just like we did on the 5-number summary, because these deal with a similar idea, percentiles and quartiles, we're going to sort our data. Okay, so if you need more time to do this, go ahead and pause the video. Otherwise, we're going to highlight this, and we're going to sort it. So here, go to the Data tab, and sort. We're good to go there. So now what we're going to do is talk about percentiles. By definition, a percentile is just how you did compared to everyone else, and that's why we practice sorting it first. Now, it is important to understand whether a high number is good or bad in this situation. So when we were dealing with the picture of the box plot, we were talking about time. A high number, when we were doing that rectangle test, was considered bad. So the highest number on there would have scored at the lowest percentile, technically. Okay? Whereas when we're dealing with this example here of this test that they gave to their employees, we're assuming that a higher score is better. So where that helps us is we're going to go ahead and put these in order of position. Okay, it's not really a ranking system, it's position. So next to the column, we're just going to do 1, 2, and number them all the way down. So how you can use Excel for this is if you highlight those two, it's recognizing that there's a pattern and it wants to count. So then you can drag down the rest all the way till you get to your last value, which should be 40. Okay, so this is the position happening. So I'm going to go over here and highlight this column, right-click, and insert a row above so that I can just label that. So this is position. And over here was the actual score they got. And what we're going to do with this is we're going to calculate the percentile. So the percentile is just the position ranking out of the total. So that's just going to be equal, grab your 1, and divide it by our total number of people was 40. Okay? What we're going to do is change that to a percent. Okay, so back over to your home. You can just click this percent button. And that says 3%. We're going to go ahead and drag that down to cover all of them. Now, there are a couple things I want to talk about. So if you're still getting caught up, pause the video until you get these filled in, and then we'll go over kind of the meaning of what's going on here. So first of all, is right now they are rounding all of these percents to a whole number. That is something that percentiles do. Now technically, when we're given the definition of percentiles are the percent of people who scored at that value or lower, if it's not coming out to a nice exact value, really we should be rounding down. Now this book and I think the homework, they round to just the nearest whole number, which means what is happening in Excel here of it rounding to the nearest whole number is just fine. Okay, so you won't have to worry about that. The next thing we have to worry about though is when we're saying that the percentile represents those who score at or below you, we want to really think about what's going on with these scores. So what we're going to do is start at the top, and the first one is 100%. Okay, the top score, technically, when we're talking about percentiles, they're not going to ever tell you you're at the 100th percentile. It's going to be represented as the 99th percentile. And that kind of goes with that rounding down idea. Okay, so the 99th percentile is really the highest you're going to see. But another thing we have to look at is the people who score the same. So as we go through here and just scroll on up, working through here, 55 is the first time two people have the same score. Well, one of these calculations says that a score of 55 represents the 58th percentile, and the second one says it's the 55th percentile. Well, if they scored the same thing, they should be representing the same percentile. Based on the definition being the number at or below, we want to use the upper one because there are 23 numbers that score at that same number or below it. So if I use this 22, it doesn't work because 55 is at that same number. So we're going to keep the higher score, and we're going to just delete out the lower score. So let's go ahead and repeat that through here for any values that happen twice. So 54, we'll delete out that lower one. We go through here. Okay, next one I see is, looks like that's all that repeat, were just those few. Okay, so now we have all our percentiles written here. And what we're going to do is go just answer the questions. We wanted the 10th percentile. Okay, so the 10% showed up here with a score of 27. And then we wanted 88. So 88 was down here with a score of 71. So 27 and 71 are the values that we need. They don't say what these are labeled as, so it's just a score. Could be points, could be percent, we don't really know. Those ones are okay to have labels. But I'm going to have you just interpret to the side so we can really drive home the meaning of this percentiles. So if this was a 10 percentile, it means about 10% of people who took this test scored 27 or less. Okay? Then, about 88% of people who took this test scored 71 or less. That's the idea of a percentile. Okay? Higher percentile you do, the better relative to the other people who took the test is. Okay, so that's actually what we just did here. We calculated the number of data values less than or equal to calculate that part, and then we got those numbers from that. So when we're given a table, we can use this formula without making a big table like we did on that second sheet. So if I want the 75th percentile, excuse me, 75th percentile, I got to think about what that represents in terms of a ranking. So we have 20 newborns here, and it looks like they're in order in terms of these columns, but I'm going to go ahead and copy them over here so we have the list. There's not as many here, so I will just put them in the same sheet. And from there, we don't have to sort them because they're already in order, but we are going to list their ranks, or their position, excuse me. Okay, there's not really good or bad in this case, but when we talk about weights, they do have lower percentile being the lower weight and a higher percentile being the higher weight. This is a really common application of percentiles is, you know, when they're talking about babies who are born like really underweight, they're in a low percentile, or as they're measuring children grow at their checkups, they represent height, weight, and head circumference in terms of percentiles. So we want to find the 75th percentile and the 35th percentile. We're going to do this the exact same way we did the last one. Position over total, excuse me. So we have 20 total. So over here, we're going to do equals, grab that over our 20, change that to a percent, and fill down. Okay, look for repeated numbers. Okay, we have some weights that ended up being the same here, the 7 and the 7. Okay, the 8.3. Let's see, and then these 5.9. So we keep the highest one, and we're going to delete out both of those other two. So we've got our percentiles. We're looking for the 75th percentile. That looks like a baby weighing 8.2. So 8.2 pounds is our answer, and that means about 75% of newborns weigh 8.2 pounds or less. Here, if you hit to deselect the wrap text, that will move it so it's not wrapping over and making a weird, excuse me. Sorry for all the pausing. But that'll get rid of the wrapping and the weird column, and then you can, if you want, do a left justification for that. Okay, similarly here, the 35th percentile looks like it goes with 6 pounds. and our interpretation is the same. I'm just going to copy it. What changes is it's not 8.2 pounds, it's 6 pounds. The or less is really important. Make sure you incorporate that because that's the definition of a percentile. Okay, it's less than or equal to that number. Okay, we can go the other direction. A baby weighed 8.3 pounds would fall in the, going here, that would be the 85th percentile. And then 6.6 pounds would be the 40th percentile. Okay, that's really all there is for this one. This last problem is just extra practice with these things. You have the option to complete that or not. At this point, I'm going to pause the video, and I'll fill these out to let you check your work if you do want to do these. But otherwise, you can start on your homework. Here are the answers for that last example, so you can check your work. Okay, remember the easiest way is to, it takes a little bit of time to recopy your column of numbers so that you can answer both numbers about the 5-number summary with the Q1 and Q3, so you don't have to calculate it by hand, and doing the percentile problems.